Good morning, everybody. Welcome to class number 11. In previous class, we have already discussed the charge distribution, the linear charge distribution, and surface charge distribution, and another is charge distribution at present. But मैंने छोड़ दिया था, सो टाइम खत्म हो गया था, इसलिए मैं छोड़ दिया था. But today, now I will discuss about volumetric charge distribution. So you can write volumetric charge distribution. The charges are distributed over a volume is called volumetric charge distribution. Yes or no? So the reference are present, the cube, three-dimensional space is the small cube. Here is the volume is the V, the small volume is the dV, the Q is present on V, then charge is present on dV is what? dQ. So from this volumetric charge distribution, the volumetric charge density are created. The volumetric charge density is denoted as rho is equal to dQ means dQ by dV. That means rho is equal to volumetric charge density. Volumetric charge density. dQ means the charge at volume dV. So we can write dQ is equal to rho dV, or Q is equal to integration of dQ is equal to integration of rho dV. So we can write that is the volumetric charge distribution. Yes or no? After this explanation, we can write or we can discuss the force about linear charge distribution, force about surface charge distribution, force about volumetric charge distribution. What is the force? What is the force due to linear charge distribution, surface charge distribution, or volumetric charge distribution? Yes or no? So we can write. So write down here linear charge, that means that is the linear, suppose it is the positive charge Q, that is suppose it is the test charge Q0, the distance between this charge is R, the force F dot on this charge is this, either suppose this is the positive charge, this is the positive charge, repulsive force is available. So F is what? F is equal to beta Q0 divided by R square, or that is equal to beta Q0, Q means integration of lambda dl by R square. We have already known lambda is equal to dq by dl or q by l. So q is or no? So dq by dl or q integration of lambda dl. Yes or no? So we can write in surface charge is what? Surface charge, this is the Q0, this is the positive charge surface area, this is the Q charge, the center of this charge, and test charge is the R. So F is equal to beta Q0 Q by R square. So beta Q0 integration of sigma ds by R square. Yes or no? Similarly, we can write this is the test charge, this is the volumetric charge, Yes or no? Positive charge. Suppose the distance between R force is what? Beta q0 q by r square. Here we can write beta q0 q is what? Just before we will discuss q is what? Integration of rho dv by r. This is the force due to linear charge, force due to surface charge, force due to volume charge. This one. So after discussion of linear charge, surface charge, volumetric charge, then one numerical problem I will discuss. The numerical problem is what? So write down the question. This is the numerical example question. The calculate ratio between linear charge densities and surface charge densities having volume charge density ratio 64 by 27. The answer is what? Here given volumetric charge density is denoted as rho. That means rho 1 by rho 2 is equal to 64 by 27. We have known rho is equal to q by v, q by v, q by v, or q by v is equal to rq, side q. Volume is what? Side q. That means rho proportional to 1 by rq. So rho 1 by rho 2, that means rho 1 is equal to rho 1 proportional to 1 by r1q, rho 2 proportional to 1 by r2q. So divided by rho 1 by rho 2 is equal to, we can write rho 1 by rho 2 is equal to r2q by r1q, that is equal to 64 by 27. So imply that r2 by r1 is equal to 4 by 3. This one. So we have to find out the ratio of linear charge density. First point, we have to find lambda 1 by lambda 2. Linear charge density is denoted as lambda. So ratio is lambda 1 by lambda 2 is equal to, we have already known lambda is proportional to 1 by r. So lambda 1 by r2 is equal to 1 by lambda 1 proportional to 1 by r1. Lambda 2 proportional to 1 by r2. Lambda 1 by lambda 2 is equal to r2 by r1, that is equal to 4 by 3. Similarly, second point, we have to find, question asks you linear, after linear, then surface charge density you have to find. Surface charge density is sigma 1 by sigma 2. Sigma already depends upon, sigma is equal to q by s is equal to q by r square. Area means square of side. So sigma is equal proportional to 1 by r square. Yes or no? So sigma 1 is equal to 1 by sigma 1 proportional 1 by r1 square, sigma 2 proportional 1 by r2 square. So divided by sigma 2 to sigma 2 is equal to r2 square by r1 square, that is equal to 416 by 9. That is the answer of numerical example. Yes or no? So then after this study of charge distribution and numerical example, the very interesting topic I will discuss, that is the electric field. So make a heading, electric field. So I will discuss about electric field. इलेक्ट्रिक फील्ड क्या है? फील्ड का मतलब तो एरिया, फील्ड का मतलब एरिया। एरिया में क्या है, इसको बोलती है इलेक्ट्रिक फील्ड। इसमें सपोज वन एग्जाम्पल, एक अंधेरे घर में एक कैंडल जलाते हैं, उसके बाद क्या होगा? एक अंधेरे घर में नहीं जलाते एक कैंडल नहीं जलाते हैं तो इस अंधेरे घर में अंधेरे होते हैं. ड्यू टू प्लेसिंग ऑफ कैंडल the lighting field is created. Suppose the candle is here, candle is here. Before placing of candle, this area is the darkness space or darkness field. Or after placing of candle, the light intensity, suppose the light intensity this to this point, this point, this point, this point. There is no light intensity because there is small, there is any सामान, यहाँ पे any सामान है तो वो सामान को हम दिखाई नहीं देता है because वो सामान के ऊपर में लाइट इंटेंसिटी नहीं आ रहा है, इसलिए वो सामान हमको नहीं दिखाई देता है. बट यहाँ पे सामान है तो हमको दिखाई देता है क्योंकि उसके सामान पे ऊपर में लाइट इंटेंसिटी आ रहा है. उसके आई सेंसिटिव, ड्यू टू आई सेंसेशन हम इस सामान को देख सकता है. ड्यू टू लाइट इंटेंसिटी वी कैन सी द एनीथिंग और एनी मटेरियल इनसाइड द फील्ड. ये सुन, ड्यू टू कैंडल द लाइट इंटेंसिटी field is modified. Before absence of candle, the area is darkness area. Up using of candle, the area is lighting area. That means from this explanation, from this practical, the area is modified. Before candle, darkness area. After using of candle, the lighting area. That means the same area is modified. Similarly, this area is there is not field. After pressing of some charge q, suppose this is the positive charge, some charge q, due to this charge some area is modified. That means this area is the electric field area. But question is come to our mind or in your mind, J, whenever candle is present, but anything can be visible, but lighting area is created because we can see, lighting area is, we can see, it is visible, सामान दिखाई देता है. That means we can see, but due to placing of charge, field is created. How to know? Field is not visible to human beings, human eye, but light intensity is visible to human eye. So that's why I can imagine, I can see the material or light intensity. But due to placing of charge, the electric field is created. It is how it is possible the field is present due to placing of charge. How it is possible? How can I know? It is not visible. How can I know? The explanation is present here. Explanation is what? Here, suppose due to placing of this charge, electric field is exist up to this point. Suppose up to this point. But we can prove, we have to prove the electric field exists up to this point. How to prove? Suppose a test charge is present here. That means a test charge is outside the field, but there is not force. There is not exert the force on that test charge. Then next step, we can try to bring the test charge nearer to this charge. This charge is called source charge. Because here a candle, due to placing of candle, light field intensity is created. That means lighting field is the source of candle. The light intensity depends upon candle. So due to candle, light intensity created. Similarly, due to charge, the field is created. The large field is created. That charge is known as source charge. That means you have already discussed source charge. Charge is distributed charge. Charge distributed this point. Charge is distributed this point. This point. This point. That means which area में चार्ज डिस्ट्रीब्यूट होता है, दिस फील्ड को इलेक्ट्रिक फील्ड बोलते हैं. सो दिस चार्ज इज सोर्स चार्ज. Yes or no? But we have to come to this point. Here, placing of test charge, there is not act on force. We try to bring this test charge nearer to source charge. Suppose this charge is here. There is no force. Suppose this charge is nearer to boundary of field. This point. So, whenever a test charge placed a boundary of this point, then force is exerted. That is the explanation. That is the experiment. Force is exerted. This point, suppose this point field is known as P. This point is named as P. Here this point is present inside or on the line, the force is exerted. That means here there is no force. Here there is no force. Here there is no force, but here फोर्स एक्ट कर रहा है. इसलिए यहाँ पे कुछ है, यहाँ पे कुछ है, इसीलिए फोर्स एक्ट हो रहा है. कुछ है मीन्स इलेक्ट्रिक फील्ड है. ड्यू टू इलेक्ट्रिक फील्ड फोर्स इज एक्सर्ट. फोर्स इज एक्सर्ट ऑन दिस पॉइंट. Yes or no? But again, we can try to bring this test charge nearer to this. Here, whenever test charge is bring to the nearer to source charge, then force is increases. ज्यादा हो रहा है. यहाँ पे जितने फोर्स है यहाँ पे ज्यादा हो रहा है, यहाँ पे और ज्यादा है. इसलिए तो टेस्ट चार्ज इज क्लोज टू दी और ब्रिंग nearer to the source charge, then force is ज्यादा बढ़ रहा है. सपोज एग्जाम्पल कैंडल केस. कैंडल में यहाँ पे जितने वो सामान उसके पास आ रहा है वो ज्यादा दिखती है. दैट मीन्स कैंडल के पास लाइट इंटेंसिटी ज्यादा है, उस दूर दूर जाता है लाइट इंटेंसिटी कम कम होता है. इसलिए हियर इन दिस केस दूर दूर इलेक्ट्रिक चार्ज रखते हैं, फोर्स नहीं पड़ रहा है. जब बाउंड्री में पड़ रहा है, इस बाउंड्री में कुछ है, वही है इलेक्ट्रिक फील्ड. सो हियर द टेस्ट चार्ज इज प्लेस्ड नियरर दिस पॉइंट, दिस पॉइंट, दिस पॉइंट. व्हेनेवर क्लोज टू दिस पॉइंट द फोर्स इज इंक्रीजेस. बट फील्ड फोर्स बढ़ रहा है, इसलिए फील्ड इज इंक्रीजेस. फोर्स बढ़ रहा है, फील्ड भी बढ़ रहा है. दैट मीन्स फोर्स इज इंक्रीजेस, देन फील्ड इज इंक्रीजेस. बट फ्रॉम दिस एक्सप्रेशन द फील्ड इज व्हाट? फील्ड कैन बी डिफाइंड. द फोर्स, सपोज दिस पॉइंट इज हियर, दिस पॉइंट P, at this point Q0 test charge is present. In this point field is exist. Field is exist. What is the value of field? Value of field is the force exerted on this charge per unit test charge Q0. So that means F is equal to Q0A is the vector quantity. Yes or no? So due to whenever a point charge, a test charge placed inside the electric field, then force exerted on that test charge. That means on this charge force is what? F. On this charge force is what? F. F is equal to this charge Q0 on and this charge placed inside this field. So this point charge into this field is equal to force exert on that charge. So F is equal to Q0. Listen, this is the basic idea of electric field. Listen, basic idea of electric field. But हम explanation कर सकता है. It is the explanation. Heading, it is the explanation. Due to explanation, we can imagine or we can find electric field is exist up to what point? Electric field it exists up to what point? That means in this figure electric field exists at this point. Yes or no? In this point, any point is present, any test charge is present, then a force exert on that test charge. Yes or no? So explanation, we can write concept of electric field. Concept we can write when an electric charge is placed at any point, the properties of space around the charge get modified. The modified space is known as electric field. This one, electric field. So you can write down. So we can draw some figure here. A point charge is present. Suppose field area is up to this point. Here Q0 test charge is present. There is no force, but Q0 charge present here. Point charge is Q0P. There is force is act. There force does not act. Force is act. You can draw this figure. This one you can draw this figure. So after this drawing, here in this point force is acted. That means up to this point field is exist. So we can write to test the. You can write to test the existence of electric field. Test the existence of electric field at any point P. At any point P. Placed any point P. Placed of small test charge. Small test charge Q0. The force exert on the test charge test charge Q0. Test charge Q0. So we can say, we can say the electric field exists up to P point. Yes or no? You can write down. So we can write down definition of electric field is what? Definition of electric field is what? इलेक्ट्रिक फील्ड इसको बोलती है इलेक्ट्रिक फील्ड स्ट्रेंथ और वी कैन से इलेक्ट्रिक फील्ड इंटेंसिटी. ये सुनो. सो द इलेक्ट्रिक फील्ड at a point is defined as force. A point defined as force experience for unit test charge is called electric field. Electric field or electric field strength. Field intensity or field strength. Electric field strength. Soon. So we can write electric field is equal to Q0. Here Q0 is the positive test charge. So F is the force exerted on test charge. E electric field. Yes or no? So we can write. So now we can write characteristics of electric field. It is vector quantity. It depends upon source of charge. ये सुन, इसका यूनिट क्या है? SI यूनिट is F/Q or Newton per coulomb. So SI unit is Newton per coulomb. CGS unit dyne per start coulomb in ESU, electrostatic unit. Similarly, another unit dyne per up coulomb, EMU, electromagnetic unit. This one dimension is what? Dimension is equal F/Q. F the force force is m1 L1 T minus 2 divided by Coulomb C A1 T1. So m1 L1 T minus 3 A minus 1. So no, m1 L1 T minus 3 A minus 1. Yes or no? This is the characteristic of electric field and a unit and dimension. Then you have to note down very important point. Very important point. The direction of electric field is same with the force exert direction with the direction of force exert on positive test charge. This is the point. Another point is available. Another point is what? Another point is the field inside the charge conductor is 0. Why? This is the basic concept. This we will discuss in next class. Yes or no?